So we can solve for k in a number of ways, but k is more complicated than just simply solving because its units vary and they have somewhat complicated units. If we look at a process here, rate equals k times the concentration of A to the 0 power. This is 0 order with respect to A, but it's also 0 order overall because the only power is the 0 on the A. In a situation like this, we need to know, well, what would the value of the rate constant, or what would the units of the rate constant be, rather? Well, rate is frequently measured in molar per second. So if we take rate as molar per second, set that equal to K, and then think about what's going to happen here. Your concentration of A raised to the 0 power, anything raised to the 0th power is going to cancel out to be a 1. So this is just molar inverse seconds equals K. Therefore, the unit of K must match the unit of the rate. So K in a 0 order overall process is simply molar inverse seconds. Let's look at a first order overall reaction. We've got rate equals K times the concentration of A to the 1st power. So again, this is first order overall because the only power is that 1. And let's go through this process again. We know the rate is going to be molar times inverse seconds, or molar per second. It's more common to see it written without using any fractions, equals K times the concentration of A, which is measured in molarity. Since these are brackets, that means molar concentration. This K is getting multiplied by some number with a unit of molarity, or molar. If we get K by itself, that should deduce for us the units of K. So we'll divide both sides by molar, and we can see that K in this situation is going to equal simply inverse seconds because the molar on top and the molar on bottom will cancel. So in a first or a 0 order overall process, your units for K are molar inverse seconds. For a first order overall process, the units of K are just inverse seconds. Now let's take a look at something that's second order overall. We've got rate. Let's go ahead and say that this is second order overall. We've got rate equals K times the concentration of A, which is being squared. So again, rate is measured in molar inverse seconds equals K. Now think about what's happening here. These brackets symbolize molarity, but then that's being squared. So we're dealing with molar squared as our unit. If we divide both sides by this molar squared to get K by itself, what winds up happening is this M gets canceled by the M on the bottom, but then this M on bottom is still there. And for that reason, can be rewritten as inverse molar inverse seconds for our units of K. And then if we go to this one here, we have a third order overall. And I know it's third order overall because the powers of the rate law, the A is 2, the B is 1, 2 plus 1 is 3. Again, rate is measured in molar inverse seconds equals K. The unit of the A is molar, which is being squared, times the unit of B, which is molar. So really, you have molar inverse seconds equaling K times molar to the 3rd power. If we divide it to get K by itself again, you'll find that you just subtract the powers if that's really what you want to do. 1 minus 3 is -2. So this is molar to the -2 times seconds to the -1st, equal your units of K. It's very important that you're able to deduce the correct units for K. And me personally, I like to just work my way through the process of what is my order overall, get K by itself, and figure out your units. Some people instead choose just to memorize that a 0 order process is molar per second, or molar inverse seconds. And then every time you increase the order overall, you're taking away a power of M. For example, this is M to the 1st power. M to the 0th power cancels, leaving you with just seconds inversed. Take away another power of m, and it's m to the negative first. Take away another power of m, and it's m to the negative second. However you want to go about this, you need to be able to correctly identify your units for k.